NASA just unveiled a telescope that is going to change everything we think we know about the universe. And I mean that literally. Yesterday, April 21st, 2026, NASA stood in front of the world at the Goddard Space Flight Center in Maryland and showed us the completed Nancy Grace Roman Space Telescope, fully assembled, fully tested, ready to launch. And here is the number that stops you in your tracks. Hubble has been the greatest space telescope in human history for 36 years. It has shown us the deepest images of the universe ever taken. It has confirmed the expansion of the universe. It has changed cosmology permanently. Roman has the same size mirror as Hubble, but its field of view is 100 times larger. What Hubble needs 2,000 years to survey, Roman will cover in 1 year. Let that sit for a moment. 2,000 years. 1 year. This is not an upgrade. This is a different category of instrument entirely. And it launches in September, 5 months from now. Let me tell you exactly what Roman is going to do. Because the two targets it is hunting are the two biggest unsolved mysteries in all of science. The first is dark energy. Right now, tonight, the universe is expanding. Not just expanding, accelerating. Every galaxy moving away from every other galaxy, faster and faster, with no sign of slowing down. We do not know why. The force driving that acceleration is what scientists call dark energy. It makes up approximately 68% of everything in the universe. It is the dominant component of existence, and we have essentially no idea what it actually is. Roman will map the large-scale structure of the universe across cosmic time, measuring how galaxies cluster and how that clustering has changed over billions of years. That data will tell us how dark energy has behaved across the history of the universe, whether it is constant, whether it is changing, whether our current model of physics needs to be rewritten. That is what is at stake. The fundamental model of physics, possibly rewritten by this telescope. The second target is exoplanets, worlds around other stars. Roman carries the most advanced coronagraph ever flown in space. A coronagraph blocks starlight, like putting your thumb over a headlight so you can see what's next to it. Roman's coronagraph will do this with precision never before achieved in orbit, directly imaging planets around nearby stars, not detecting them indirectly from wobbles or transits, actually seeing them. It will also conduct a gravitational lensing survey of the galaxy, detecting tens of thousands of new planets, including Earth-sized worlds in habitable zones that current telescopes simply cannot find. Roman is expected to discover more new worlds in its first 5 years than every telescope in history combined. Now let me give you the scale of what this instrument is actually going to produce, because the numbers are almost incomprehensible. Roman carries a 300 megapixel infrared camera. The images it will take will be so large there's not a single screen in existence large enough to display them at full resolution. In its first year of operation, it will send 11 terabytes of data back to Earth every single day. In year 1 alone, Roman will transmit more data than Hubble has produced in its entire 36-year lifetime. Over its 5-year mission, it will measure light from over 1 billion galaxies, map tens of billions of stars, detect thousands of supernovae, discover planets we didn't know existed. And it will do all of this from 1 million miles away, parked at the same gravitational sweet spot as the James Webb Space Telescope at the second Sun-Earth Lagrange point, where gravitational forces balance to keep it in a stable orbit with almost no fuel required. Hubble gave us a keyhole view of the universe, the most extraordinary keyhole view imaginable. But a keyhole. Roman gives us the wide lens, the panorama, the census of everything. Here is what this means for the questions that have kept astronomers awake for decades. 95% of the universe is invisible to us. Dark matter and dark energy. We can see their effects, but we cannot see them directly. Every galaxy we observe is held together by dark matter we cannot detect. Every measurement of cosmic expansion points to dark energy we cannot explain. Roman will not solve these mysteries overnight, but it will generate the largest, most precise dataset ever assembled about how the universe is structured and how it has evolved. And in that dataset, somewhere, are the answers that have been hidden from us since the beginning of cosmology. NASA Administrator Jared Isaacman said it at the unveiling yesterday. The most exciting science from Roman will be the things nobody predicted, the discoveries nobody saw coming, the questions Roman raises that we don't even know to ask yet. That is the promise of a genuinely new instrument, not better answers to existing questions, entirely new questions. So, when does this happen? Roman ships to Kennedy Space Center this summer. Launch is targeted for late September 2026, 8 months ahead of its formal deadline. Under budget. On a SpaceX Falcon Heavy. Drop a comment right now with what you think Roman will discover first. Dark energy breakthrough, a new Earth-like planet, or something nobody has predicted. Because in 5 months, this telescope opens its eyes for the first time, and the universe will never look the same again. Subscribe to Deep Sky Nexus. When Roman launches, when the first images come back, this channel will be here to show you exactly what you are looking at and why it changes everything. The keyhole is closing. The wide lens opens in September.